So in this lesson, I'd like to show you how to calculate slope in a slightly more algebraic form. We've already done this a little bit before when we were looking at calculating rates of change when we're modeling real life situations that are best modeled by linear relationships. So we'll go back there first, and I'll show you how we did it before, and then we'll see if we can link it to how we would calculate it when we've got lines in the form y equals mx plus b. So this was an example that we looked at in the past. It's the journey of our motorcycle. We've got our dependent variable as our distance in kilometers, so that's our y, and our x, or our independent variable, is time in hours. And if I want to calculate my rate of change, I know my rate of change is going to be my rise, or my y's, over my x's, so kilometers per hour, so the velocity or the speed that the motorcycle is taking. So if I wanted to do this before, and I had a graph that looked like this, what I would probably do is I would pick a couple points on that graph, and it wouldn't matter what points I picked, because no matter what points I pick, I'm still going to have that same constant rate of change throughout the example. So when I was doing this, I picked the point 1 and 80, and I picked the point 4 and 320. So after 1 hour, 80 kilometers were traveled. After 4 hours, 320 kilometers were traveled. And from there, I would start on my left. I would draw my rate triangle. So I would go up and I would go over. And I'm going to look at my scale to figure out how far up and over I went. So if I start at 80 and I go up to 320, I know that I've gone up 240 kilometers. If I start at 1 and I go over to 4, then I know I've run 3 hours. So when I'm calculating my rate of change, then my rate of change was equal to rise over run. So I can see that my rise was 240 kilometers. My run is 3 hours. And then, of course, I want to put it into a unit rate. So I'm going to take 240 divided by 3. So I've got 80 kilometers per hour. So this motorcycle is traveling with a constant speed of 80 kilometers per hour. Okay. So what I want you to be able to do is I want you to be able to take this type of example, and instead of having to draw the graph, I want you to be able to take just 2 points on a line. So if I just took 180 and I took 320, and I wanted you to calculate the rate of change using just those points, can we quickly calculate the rate of change or the slope that way? So before we move to the next slide, I just want you to see a connection here. So first of all, I think I'll start with my x. So if you look at the number 3, where does that number 3 come from? Well, we started at 1 and we went over 1 to 3 hours to go from my left to my right of my right triangle. However, if we look at the actual numbers of the x's, my x here is 4, my x here is 1. Well, how do I get 3 from 4 and 1? Well, I take my 4 and I subtract my 1 to give me what's left over in between them. So 4 minus 1 gives me my 3 hours. Okay. Same thing goes for my rise. So with my rise, what I did when I was using my right triangles, I started here and then I counted up. So I started at 80 and I went up to 320. Well, I know that 320 minus 80 is equal to 240. Okay. So if I just know the points, I don't necessarily have to have this graph of the line and draw the right triangle. What I can do is I can say, okay, what is the change in my x? So 4 minus 1 to give me my 3. And what is the change in my y? 320 minus 80 to give me 240. And then I can take my change in my y, which is my rise, divided by my change in my x, which is my run, and I'm going to get 80 kilometers per hour. And I've written that out for you so that you can see it here. Okay, so if I take my 0.1, 180, and I take my 0.2 for 320, instead of writing rise over run, I'm going to write it using a slightly more algebraic method. And instead of writing rise, I'm going to write delta y, because delta y, the symbol delta, is one that you'll often see in science, and it's used to describe a change in something. So this means the change in y divided by the change in x, which is our run. So rise over run becomes the change in y divided by the change in x. And now if I want to kind of get even a little bit more technical here, what I can do is I can say, well, I know that the change in the y is going to be equal to my 320 minus my 80. Well, the 320 is the y coordinate of my second point, so I'm going to call that y2. And I'm going to subtract the y coordinate of my first point, so I'm going to call that y1. So my delta y, my change in y, or my rise, becomes y2 minus y1. Same thing for my run. So my run becomes my delta x. In order to find that delta x, we did 4 minus 1. Well, the 4 is the x coordinate of the second point. The 1 is the x coordinate of my first point. So I'm going to call this x2 minus x1. So y2 over y1 is my rise. X2 minus x1 is my run. And now I don't have to worry about drawing a graph to be able to figure this out. I can just take my 2 points. I can label my points point 1 xy, point 2 xy, and then I can sub in my values, and I get my 240 kilometers over 3 hours, which works out also to be 80 kilometers per hour. Okay? Another way you can think about it over here, so if you just draw out or write out your 2 points, so I've got my 180 and I've got my 320, I can almost think of it as if it's in a table of values. So this is kind of a numerical approach here. So I know that to go from 80 to 320, my delta y is going to be my 240, which is what I have here. And my delta x, or my change in x, is going to be 3. So 1 to 4 is a change of 3. So I've got 240 over 3 to give us our 80 kilometers per hour. So in the past, when we were modeling situations, we drew out our models, we created our rate triangles, we calculated our rise over our run, or we used our table of values, figured out our rise, our change in our y's, change in our x's, figure out our runs, and we calculated it using the rise over run formula. But when we're dealing with purely algebraic equations, then we might want to write it a little bit more technical, delta y over delta x, or y2 minus y1 over x2 minus x1. Okay? So what you should be able to do now is be able to calculate slope using 2 formulas. We can now determine the slope of a line 2 ways. If we have a point x1, y1, so this is point 1, and point 2 is x2, y2, then we can use rise over run if we want to draw a right triangle. Or if we know the 2 points, we just take our second y value and subtract our first y value, and take our second x value and subtract our first x value. So we now have a new formula that we can use to calculate slope. So let's just practice using this. So what I'd like you to do is to determine the slope of a line that contains these 2 points. So I've got point 1, which is -2, -1, and I've got point 2, which is 4 and 3. And what I'd like you to do is take a second and pause the video, see if you can use one of the formulas to calculate the slope of that line, and then I'll show you some of the solutions that I came up with in a minute. So pause the video, try to find the formula of this, or try to find the slope, and we'll go from here. Okay, so here's a couple different ways that I solved it. So first of all, I could have just drawn my 2 points. So I've got -2, -1. I've got 4 and I've got 3. So using those 2 points, I could draw my line. I could draw my right triangle. I know that rise over run is equal to 4 over 6 if I actually count it, or in lowest terms, 2 over 3. So that's one way we could do it, okay? But if I didn't want to draw this picture anymore, what I could do is I could just look at the points now. So I could say, okay, well, if I was to put these points in a table of values, I would have -2, -1 as one of my points in the table of values. 4, 3 would be the other point in my table of values. And now I can say, okay, well, that means the rise is 4, the run is 6. So rise over run is 4 over 6, or 2 over 3. Or I could just look purely at the points without drawing my table. So I could just write my points like this. And I know to go from -1 to 3, I have to rise 4. To go from -2 to 4 on my x's, I have to run 6. So my slope would be 4 over 6, which is 2 over 3. But finally, I can use my new formula to do that. So if I take those 2 points, I'm just going to write them here at the side. So I've got my -2, -1, and my 4, 3. And I always like to label things so that I can make sure I'm keeping my my notation correct. So this is the point I'm choosing to be the first point. So we're going to call that x1, y1 because it's my first point. And this is the one I'm choosing to be my second point. So I'm going to call that x2, y2. And if I know that slope is equal to y2 minus y1 over x2 minus x1 using the new formula that we've learned, then I can plug in my values. So my y2 is my 3, subtract y1, which is negative 1, over x2, which is my 4, minus my x1, which is negative 2. So I've got 3 minus negative 1, which I know when I have that double negative sign there, it's going to turn into a plus. So that becomes 3 plus 1, which is 4. And then I've got 4 minus negative 2. That becomes a plus sign. So I've got my 6 here. 4 over 6 becomes 2 over 3, just like I found up here. Okay, so we can kind of do it from a geometric point of view where we're looking at the picture of it and we're using the rise over the run. But now we can also find slope using a more algebraic method, using our slope formula, y2 minus y1 over x2 minus x1, or delta y over delta x, and then calculate our slope using that.